yesterday, and on the back are all of these simplification problems. So this is 9 through 12. I put 9 through 12 up here. All right, so here we go. You now have, let's say this is test question, and you have to do this. What would you do? This is all the first problem. What would you do with that big, long, hideous mess? Maya McLaurin.
Tan equals sine over cosine.
Perfect.
And then cotangent is 1 over tan. Well, no, you can do sine over cosine. Cosine over sine.
Okay, that's probably a better thing to do, cosine over sine.
You
Okay.
can have sine over 1.
Yep.
Okay, and then you can have 1 over cosine.
Perfect. So now, we got it all in terms of sines and cosines, because she's memorized what she's supposed to memorize, and now we just start crossing off. So the sines cancel and the cosines cancel, and what are we left with? Sine over cosine, which you may leave as sine over cosine, but if you want, you can write it as tangent. Either one of those is perfectly okay. All right, remember how hard those were in the beginning? Well, they're getting easier, aren't they? Okay, now we have this one. Jack knows that's something. He's getting out his purple sheet, checking it out.
Cosine squared.
1 minus sine squared is cosine squared. 1 minus sine squared is the same as cosine squared. That's supposed to already be on your purple sheet. If it's not, let's get it there. 1 minus sine squared is cosine squared. So we have cosine squared over cosine. You have 2 cosines on the top and 1 on the bottom. You're going to cancel and be left with 1 where? On the top or the bottom? Top. The answer is cosine. It just reduces to cosine. Okay, now we have this one. Okay, now look at your purple sheet. You have on your purple sheet 1 plus tan squared is secant squared, right?
Yes.
So if you rearrange this equation, which you're allowed to do, and you subtract 1 from both sides, what would the new equation say? Tangent squared equals secant squared minus 1? So what does secant squared minus 1 equal? Tangent squared. So now we have tangent over tangent squared.
1 over tangent.
Can we cancel?
1 over tangent.
Yes. Be careful though. Who has more, the top or the bottom? So when I cancel, the leftovers will be in the bottom. So this isn't tangent, this is 1 over tangent. If you want to write that as cotangent, that would be absolutely fine. You do not have to. You do not have to. You can leave it as 1 over tangent. How about this one? This is not on your purple sheet. There's nothing that says tan plus cotan. Those special formulas all involve squares. If they're not squared, you don't have them. So what are you going to do, Jack?
Do you make that sine over cosine?
Can? Yep.
Is it just
Sine over cosine plus cosine over sine. Now, if these were being times, they would cancel.
But it's just 1.
But they're being added.
So is it just 1?
No, it's not 1. What do we do when we add? Common denominator. So our common denominator will be a cosine and a sine, right? That will be our common denominator. So add these 2 together. So this one needs to be times by sine over sine. because it needs a sign. This one needs to be times by cosine over cosine. Now, do they both have the same denominator? Yes. What's the numerator then? Sine squared
Cosine squared.
plus cosine squared. Oh, your little Valentine heart should be pounding away. What's sine squared plus cosine squared?
1.
1. So you have 1 over cosine sine.
No.
Now hang on to that quiz. I promised you to do a few each day. Hang on to it. Now I want you to get out your practice test that I already gave you. You all have one. I have one somewhere.
Sorry. I had to do this because you'll
Okay, everybody is looking at practice test 1. Over sections 5.1, 5.5, and 5.6, we have a test on Friday. We are going to be ready. All right? We're going to skip around on this a little bit. We're going to start, though, with part 1 because it's these simplifies. And this might be the hardest thing we've done. So let's take a look at it and figure it out. So here we go. We're going to simplify sine cubed plus sine cosine squared. Now, did you say that? You do factor. That's exactly what you do. You're going to factor it. Because, I mean, if you stop and think about it for a minute, there really isn't anything else to do. You can't change into sines and cosines because you already did that. It's already that way. There's no cubes on your purple sheets. You're not going to be able to do anything with that cube. So what do? Abby says, I could factor out a sine. If I factor out a sine, because I got sines here and sines here, what would I have left if I took out one sine from this? Sine squared. Plus, what would I have left if I pulled the sine out of this? Oh my gosh. Look at that parentheses. Pitter patter goes your heart. That's 1. So we have sine x times 1, which is just sine x. If you haven't yet memorized that sine squared plus cosine squared is 1, you're in trouble. You need to get that learned.
Okay. Miss Ford,
Number 2.
what you doing this weekend?
Well, when I get done putting in another detention for you in that sweater, I don't know. I'll figure out something more fun to do.
Well, do you think maybe I could spend my detention with you and maybe put it
Here we go. What is your thought process on this one?
Sine.
Cosine over sine.
Change it into sines and cosines. So, what's cotangent?
Cosine over sine.
Okay, so I have cosine over sine. Over, what's cosecant? 1 over sine. Now, you guys, This is a fraction divided by a fraction, right? So one strategy you have is to say that's cosine over sine times sine over 1. Aren't you allowed to invert and multiply? And what happens now? This is a multiplication. What happens? They cancel and you are left with cosine. Now, that's the first section. You just had 2 of those little simplifies. Guess what your test looks like? 2 of those little simplifies. Wow. Now I want you to turn over. We're going to do part 3. We're going to do the whole thing if we have time, but I want to do the hard parts. Make sure I get them done. Part 3. How many triangles are possible? Show your work. Now, we had one of these on our quiz the other day. And what work do I need to see? If you're going to tell me that there are 2 answers, because sometimes there are, I don't know on this one. But if you're going to tell me that, what do I have to see? 2 angle C's. You have to show me what those angle C's are going to be. Well, let's see. How do I set this up? How do I get started?
Sine 61 over 14 is equal to sine C over 12.
Perfect. So when I cross multiply, and then I divide, I am ready to type it on my calculator. You will have a calculator for this whole test. You'll need a calculator on almost every single problem. So we type in 12 sine 61 divided by 14. Did you get a decimal?
Yeah.
Now what do you do with that decimal? You are
Second.
not done. You second sign, second answer. And I got 48.56. Did you?
Yes.
Now, what do you do immediately at this point? You draw a second triangle, and you say, okay, that's 61, 12, and 14. What could this other angle be? If there is another answer, what would it be? 180 minus this, right? Which would be 131.44.
Nope.
Is it okay to have a 61 and a 131 in the same triangle?
No.
No way, Jose. Because what do we know about the angles of a triangle?
It's
180.
They got to add up to 180. And already you've got 190 something, don't you?
Wait.
So this triangle does not exist.
no go.
So what's the answer to the question?
Try.
1. This one right here. 1 triangle is possible.
Wait, how did you go with the 131?
These two are always supplements of each other. So whatever this one is,
You add
subtract it.
61 and 48?
No, Abby, listen to me.
Oh, sorry.
Whatever this one is, you subtract it from 180. It doesn't have anything to do with the 61. You subtract it from 180 to find that second angle. In this case, it's too big. So we had to not use it. Let's try the next one. Abby, pay attention here. We're going to do the next one. Same exact directions. So what's the setup? Tyler Decker, give me the setup.
For me, sine 52 over 6 equals sine C over 10.
Okay, so then we'll cross multiply. And we're hoping to get an answer out of this. Some of you are spoiling the surprise.
It doesn't work.
How many triangles are possible here?
None.
None. There are no triangles possible because when you try to second sign, you got this decimal. When you tried to second sign it, you got an error, right? That tells you there's no triangle, so you're done. You move on. Okay, one more of this kind. Ready? Here we go. Setup. Veronica Stemke, setup.
Sine 68 over 19.
Perfect.
Sine C over 1.
You are exactly on target. So now we cross multiply. And we type it in. Okay, I'm going to get an answer this time. I got 77.42. As soon as that happens, as soon as I get 77.42, I immediately do what? Well, I go over to the side here and I redraw my situation and I see if 180 minus 77, which is 102.58, is that possible?
Yes.
Could I have a triangle with a 68 and a 102? Yes. So how many triangles are possible this time? Both of them. Both of them. Okay? Now I want to say something. The test as usual is formatted exactly like this. There is no guarantee though that on the test, because there's 3 problems there, that one will be 0, one will be 1, and one will be 2. Last year, they all had the same. They all had 2 solutions. And that threw the kids off because they were thinking one problem would have none, one problem would have 1, one problem would have 2. That may or may not be the case, okay? It's the case here because I want you to practice each kind, but the test doesn't necessarily have 0, 1, and 2. Clear? You got to do each problem and see what happens. Okay, last that I want to do out of order is on the back page. These are word problems, so I want to go through these with you. We did these yesterday, and I think they're pretty easy, but just in case, we'll practice a little bit more. Number 1, we're on the back side doing the word problems. Find the area of a regular octagon inscribed in a circle. So here's our circle. Octagon. 8. So I'm going to make 8 evenly spaced hash marks around my circle, and then I'm going to connect those hash marks, and there is my octagon. I know that the radius of the octagon is 12. Now draw at least 2 of those in. You don't have to draw all 8 of them, but you're allowed to, of course, if you want. But we need to draw at least 2 of them because what shape are we shooting for here? Triangle. We want to find the area of this triangle because we know if we can find the area of that triangle, we'll just times it by 8 to get the area of the whole thing. Okay, so tell me, do I know anything else about that triangle? This angle is 45 degrees. How do we know that angle is 45?
360.
All of these make 360. There's 8 of them. They're equal. So each one of them is 360 divided by 8. Now, how do I find the area of a triangle in that kind of situation? 1/2 side times sine of included angle. That's our new formula we learned yesterday. 1/2 sine of included angle. Okay? I turn this phone off, it keeps dinging.
Sorry, I'm just going up right now.
Okay. Now, can you type that in for me? Suzanne, got this typed in? No. Okay, would you do that, please? I know you're excited to get on to the next problem, but we need to type it in. So we're typing in 1/2 12 sine 45. Got it? Now, that's not the answer though. No, we don't have to second anything. What do we have to do with that? She's got this sitting on her calculator. She needs to times it by 8. So the area of the octagon will be 8 times the area of the triangle, right? Did anybody get an answer? 407.29. 407.29. And that would be square inches. Are we good on that? Question number 2. Find the length of the shorter diagonal of a rhombus whose size measures 16. Anybody know what a rhombus is? It has 4 sides that are equal. It's a parallelogram with 4 sides that are equal. So here's your rhombus. The sides are all 16. And the smaller angle is 34. Does that picture make sense to you in terms of the words? Okay? Kaylin, you with me here? All right. Find the length of the shorter diagonal. Now, you know what diagonals are. When you draw in the diagonals, this would be one diagonal, and this would be the other one. Which one's the short one? This one?
That one.
Or this one? First or second?
First.
First is the short one. A parallelogram is always going to have one diagonal that's shorter than the other unless it's a rectangle. Okay? So I want to find the length of the shorter diagonal. It does not say find area. Don't get confused. It says find the length of the shorter diagonal. Okay. Do you see a triangle in that picture? If you want to find a piece of a triangle, you're going to use the law of sines or the law of cosines. You're not doing area. You're going to find the law of sines or the law of cosines. Okay, wait a minute. Which one is going to work on this triangle? Don't worry about the rest of this stuff. That's not important. Is this going to be a law of sines or a law of cosines? It's got to be cosines. Because, gang, in order to use the law of sines, what do you have to have? Don't you have to have a pair? And I don't have a pair. Okay? Bryce?
Couldn't you just do the Pythagorean theorem?
Is that a right triangle?
Shut up.
No. That mistake is made all the time. Right triangles are great. The problem is I don't have one.
Okay.
So here we go. Tim?
It's okay.
Tim, was your hand up?
Yeah, I did 180 minus 34, and then I got 46 times 5 by 2.
And what was your logic? It's excellent. It's perfect. Well, what was it? Okay, but you're not always going to be able to do that. What made this special and made you able to do that? That the sides are congruent, which means this triangle is isosceles, which means these angles would be congruent. That will not be the case in a regular parallelogram. So you are right on target. Then you can use your law of sines. So you did and you got an answer. I'm going to go ahead and use the law of cosines because this problem will probably not be a rhombus the next time you see it. So I'm going to go ahead and do the law of cosines, but your logic is right on target, Tim. It's absolutely flawless. Law of cosines says x squared equals 16 squared plus 16 squared minus 2 times 16 times 16 times the cosine of 34. I want to remind you when I do the law of cosines that there is one number over here all by itself, and it is the number that is across from the angle. Everything else in the middle involves the other two sides. They just happen to match in this case. There are no variables in there, so I'm going to type all that in just one big swoop. 16 squared plus 16 squared minus 2 times 16 times 16 times cosine 34. Now, don't forget, this is always, we always get excited and forget this. When you get all that typed in, you get a number. Is that the answer? No, we have to square root it. I got 9.36. Tim, is that what you got?
Yeah.
Yep. Now the next problem says find the area. Now I went ahead and I put up my whole rhombus again because I'm finding the area of the whole rhombus. But we talked about yesterday, I think, that we don't want to find the area of the rhombus. We want to find the area of a triangle. So let's look at the scenario that we have. Could we find the area of this triangle right here? How would that look? The area of the triangle, how would that look? 1/2. 16 times 16, sine 34. Olivia?
Are we gonna count off for like not putting centimeters or inches?
On the area problems, yeah, you'll need to put your, and, oh yeah, I guess on this one, this would be centimeters right here. You're right, Olivia, thank you. Because that was the length of a diagonal. And this one's going to be square centimeters. Let's see, what is it? I got 71 for the triangle here. Did you?
Yeah.
Okay, don't get excited. What do we need to do to that to get the area of the rhombus?
About 2.
We got to times it by 2. So my rhombus has an area of 143.15 square centimeters. If you are finding an angle or a side, you're going to use the law of sines or cosines. Don't do area unless it says find the area. All right, and then number 4. Now we have a regular hexagon. What does that mean? 6. So I'll draw my circle. I'll make 6 equal hash marks. Connect those, and there's my hexagon. I know the radius of my hexagon is 14. So all of these are 14s. Now we want area. Some of you are already typing away. Before you can find area, you need to figure out this angle. How big is this angle?
30, 60. 60.
It's 60. How do I know it's 60? 360 divided by 6. Because this is 360 all the way around, right? And there's 6 of them. So the triangle area will be 1/2 14 times 14 times sine 60. So I can type that in. But please don't write that down in the answer blank, because that's the area of the triangle. How do we get the hexagon? It's the triangle times 6, right? 50922. And that is that centimeters? That's inches. All right? Now, I just did part 1, part 3, and part 5. So what I want you to do now is look at parts 2 and 4 and tell me what you think we need to do. We might get it all done. There's only 5 problems there, which
Could you go over the one theory that we
all right, let's look at part 4C. Number 4C, it's an area problem. It says find the area. But what do you notice about the triangle in part C? We have all 3 sides. And yesterday we learned that the quickest, fastest, easiest way to find area, if you know all 3 sides, is to do what? Hero's formula, right? And who remembers? Hero's formula is a big radical with 4 numbers in it. That's what Hero's formula is. Maya? So step 1, hang on Maya. So step 1 is I need to find the perimeter of my triangle. What's the perimeter of my triangle? 28. So then I'm going to use, like Maya said, the semi-perimeter, which is half the perimeter, it's 14. You've got to calculate that to get started, and that's what goes right here. So your big radical has 4 things in it. The first thing in it is the semi-perimeter. Then Maya, do you remember what we do next?
One side.
Exactly. So you're going to take 14 minus 11. Order doesn't matter. So 14 minus 11 is 3. 14 minus 8, 6. 14 minus 9, 5. You're going to have a calculator on this whole test. So if you're worried about doing that subtraction, you can do it on your calculator.
Thank you.
Now we just multiply all these together and take the square root. And that's our answer. So 14 times 3 times 6 times 5, square rooted, I got 35.50 if I round off to the nearest hundredth. Now, I want you to look at 2B. Because the triangle in 2B looks a lot alike. I mean, it looks like what we just did. But the directions are different, kids. So we are going to do totally different things. What are the directions for 2B? Solve the triangle. It doesn't say find area. We only do this when we want area. You want angles. You got to find the angles of this triangle. To do that, you're either going to use the law of sines or you're going to use the law of cosines. It's got to be cosines, because what do I not have? I don't have a pair. So I'm going to have to do the law of cosines. Pick an angle. It doesn't matter. Pick one to get started. Which one do you want to find?
D.
D. We're going to find angle D. If we're finding angle D, then we have an equation we're going to write out. 12 squared equals 10 squared plus 16 squared minus 2 times 10 times 16 times cosine D. There is a variable in here, so you cannot type this in. There's a variable in here, in this string, so you can't just type it in. We're going to figure out each piece. We got 144 equals 100 plus 256 minus 320 cosine D. Now again, you have a calculator. Do as much or little of that on your calculator as you want. See these two? They got to come over here. Right? I'm trying to solve for my variable. So I got to get rid of these numbers. So this is coming over and this is coming over. So I have 144 minus 100 and minus 256. So I've got negative 212 equal to negative 320 cosine D. Is everybody still with me?
Can you add the 100 and 256?
And subtract them in one? Yeah, it's the same thing, yeah.
You got
Now
two.
I'm going to divide. Now when I divide by negative 320, I get a decimal, don't I? Is that decimal the answer? No. What do I have to do to it? Second cosine, second answer. And that angle D is 48.51. Did you get 48.51? You are not done. Notice there's 3 answer blanks over there. You just filled in D. What do you want to do now?
Sine.
Now you have a choice. You could do exactly what we just did for a different angle. Or, now that you have angle D, you could do the law of sines. It is completely up to you. So if we do the law of sines, because it's usually quicker, we would say sine 48.51 over 12 equals sine F over 10. And we'll cross multiply. And divide. And once again, though, please pay attention. When you type in 10 sine 48.51 divided by 12, you get a decimal. It is not the answer. What do we have to do? Second sine. Remember last time we second cosine, because it was a cosine problem. 38.63. Geez, this is like the never-ending problem. We're still not done. Now we need another angle.
Can you just try?
Could you do the law of cosines again? You could. Could you do the law of sines again? You could. But let's not. Let's just recognize that the triangles add up to, or the angles add up to 180. So if I have a 48.51 and a 38.63, my other angle must be 92.86. If I added right?
Yeah.
So here's what I'm trying to point out to you. We're gonna be doing two different things on this test. When you see the triangles, you're either gonna find area or you're gonna find sides and angles. If you're finding area, you've got your area formulas. If you're finding sides and angles, you need law of sines or law of cosines. Homework for tonight is to finish practice test 1, what we haven't finished, which isn't very much. Okay? That's homework for tonight. Come with it done. Tomorrow, we are going to have a little quiz to make sure you know your law of sines and cosines. So make sure you have a calculator.